So how do they do it? How does it work? What are the mechanisms by which females can do this? We'll go through a bunch of different mechanisms of female control. Now, first and foremost, you can just stop sex. A really good example, like this is, like a fairly obvious way of doing it. A classic example is the water strider. There are some. We're going to meet water striders later in the module extensively. But in water striders, the females have genitalia which is covered by what effectively is like a manhole cover, which is a kind of an airlock which locks so securely that there is no way that a male can get in. And so a female has ultimate control over whether or not a male can copulate with her, and she can terminate copulation at any point. So we'll meet some of the different interesting male ways around that problem in a later lecture. But effectively, females have ultimate control over copulation in water striders with this kind of lock on their genitals. We're going to put some beans on that because we're going to come back to it a couple of times in later lectures. So when females have control over copulation, you get a situation where females will kind of in these bush crickets where you have a similar situation, males have got organs which specially evolve to stimulate a female to prevent her from doing this. So they have these organs called the titillators, which are these little devices here right next to a male's genitals. And within the female, this Wolf paper did some really amazing 3D video of males in copulation with females using these titillators, the yellow things here, to kind of like lightly rub against patches of sensory cells within the female. You can watch it on the video. I don't have the video actually here, but these are kind of stills from it, from the paper. Actually kind of rubbing against sensory bits within the female and kind of stimulating her to not stop copulating. So it really works. It really forces the male to try and induce the female not to stop. You can, wait till sex is done, but then remove the sperm of the male. And the pinnacle of this is in crickets, where the male deposits his sperm in a little bag called the spermatophore, and it's deposited externally, so outside of the female. And the female will often just turn around and remove this, especially if the male is non-preferred. So she can rub it off against the wall, she can turn around and eat it. It's this little device here. And she can just remove that, and that allows the female control over whose sperm gets to stay there. You can spit out or eject, or you can digest, or you can otherwise neutralize the sperm of males that you don't like. The classic example here is chickens. Chickens will very commonly, if a male is unwanted, if a male has kind of copulated with a female and she didn't want it, she will just eject the sperm directly afterwards. So she has control over whose sperm gets to stay in versus be ejected. You can have different ways of biasing the sperm that gets to be taken up by your reproductive tract. So one example here is Drosophila pseudoobscura. Again, the female has a spermicidal reproductive tract. So sperm which are of lower genetic quality, that are not resistant to this, will get digested, will get neutralized and digested. And only the strongest sperm will be able to make it through this gauntlet-style environment to get to the eggs. And as I said before, the males have this strategy where they have non-functional sperm that forms a protective coat around the real sperm and ferries them to the ovaries, which is a proper example of sperm social behavior. You also have things like physiological responses like an orgasm. So this paper here looked at orgasmic responses in macaques and found that females were more likely to display signs of orgasm during copulations with rivals that had higher status. And I love the fact that they controlled for the number of pelvic thrusts in their, in their examples. But the orgasm is something which biases the uptake of sperm. So if you have an orgasm, you're more likely to use those sperm for fertilization. So that's another way that females can bias sperm uptake. You can differentially store the sperm of some males. So the dung flies was the study organism of Jeff Parker, who originally coined the term sperm competition. And they have 4 different spermathecae. They're not content with one, they have 4. And then, so if you kind of have sex with a poor quality male just to kind of stop him harassing you, but then the female can store his sperm in one of her spermathecae and then just kind of put it on the back shelf and never use it again. That allows her some control over who gets to actually fertilize her offspring. So differential storage. And then there's some even more complicated hypotheses about how females can use genetic compatibility. So, for example, at the histocompatibility complex loci, the very, very diverse genetic loci that allow you to recognize kin, for example, also allow you to see which males are most dissimilar and will produce offspring with the highest degree of diversity, allows you to avoid inbreeding and maximize the immune diversity. There's this hypothesis that a male sperm carries what these guys call a molecular passport, kind of advertising the identity of a male and allowing females to choose the ones which produce the best, the most viable and the most compatible sperm. So kind of complex sperm egg signaling. This is what these guys are hypothesizing. Okay. So lots of different mechanisms of cryptic female choice. Of course, there's always going to be a paper which comes along and goes, what about males too? What about the opposite sex? So along come Ormont and Schuker, and they say, well, males can bias close copulating mating effort, depending on the traits of the female as well. So they can do things like select females based on genetic compatibility. They can select, you can vary the various different behaviors and traits of males that they can vary depending upon the attractiveness of the female that they're mating with. So you can vary the degree of mate guarding. They can vary the degree of how they use their, for example, titillators to stimulate the female. They can vary the number and the quality of the sperm depending upon traits of the female, not just depending upon competition-related traits, but also to do with choice. So that paper there goes through lots of potential, very new. This is a 2018 paper, so it's very recent idea. So not very much study has been done on this, and not very many examples. But these guys put forward some hypotheses for how males